Zoax.net. Lesson 6. Conditionals. Conditional statements select sections of code that are executed when certain conditions occur. The most common conditional statement is the if statement. An if statement uses a Boolean value to determine whether a portion of code should be executed. It is written with an if to say that if some certain value is true, then this code should be executed. In this first program, I have an integer variable I number that is set to 14. The first conditional is an if statement that checks whether the value of I number is greater than 10 and executes the code inside the block if it is. In this case, the value 14 satisfies the condition, so the message inside is printed. The second conditional is an if statement that checks whether I number is greater than 20. Since it is not, the code is not executed. The third conditional is an if-else statement. An if-else has two branches. The first branch is executed if the condition in the if is true, and the second branch is executed if the condition is false. This statement checks whether I number is greater than 30. Since it is not, the second else branch is executed. Executing this program, we see that the message from the first if statement was printed. The message from the second if statement was not printed. Finally, the message from the else branch of the third conditional was printed, as expected. These are very straightforward, but in practice, the Boolean expressions that are evaluated can be quite complex. In the second program, I introduced the else if statement. Like the else statement, else ifs are appended to an if statement. Also like the else statement, the else if creates a branch that is executed only when the previous if statement is false. However, the else if adds a new condition for its execution. In this program, I use the same variable with the same value. I begin with the first if statement that has a check to see whether the value of I number is less than 10. If so, that branch executes. If not, the next else if condition is checked to see whether I number is less than 12. If it is, that branch is executed. If not, the next else if is checked to see if I number is less than 14. If it is, that branch is executed. If not, the next else if is checked to see whether I number is less than 16. If so, that branch is executed. If not, the final else branch is executed because there is no condition on it. Notice that no matter what the value of I number is, exactly one of these branches will be executed. That is always the case when there is an else branch. But we could write an if-else if with no else branch also. The else is not necessary. Executing this program, we see that the first three branches were passed up and only the fourth branch was executed. The nature of if-else if checking allows us to say that the value is between 14 and 16 because the previous checks all had to fail before the fourth one was successful. So we always get an interval range for each of the else if branches. In this third program, I introduced the ternary operator. It is usually referred to as the ternary operator because it is the only operator that acts on three values. However, it is probably more descriptive to call it an if-else operator. Like the other conditionals, it acts on a Boolean. The other two values that the operator takes are the values of the expression if the Boolean is true and if the Boolean is false. The ternary operator takes this form: Boolean, ? True expression, : false expression. So the Boolean gets evaluated and the expression has the value of the true expression if the Boolean is true and the value of the false expression if the Boolean is false. In this program, the variable sMessage is set to the value of the result of the ternary operator. The ternary operator checks whether I number is less than 10. If it is, sMessage is set to the value less than. If it is false, sMessage is set to the value greater than or equal to. The value of sMessage is concatenated into the string that is printed. Executing this program, we get the message that the number 14 is greater than or equal to 10. The part of that statement greater than or equal to came from the sMessage variable and was set by the ternary operator. Note that the ternary operator is not strictly necessary. We could have just as easily set the value of sMessage with an if-else statement, but the ternary operator offers a slightly more compact implementation. In this final program, I introduced the spaceship operator that looks like this, hence the name. This is an operator like the ternary operator, and its evaluation is conditional. What the spaceship operator does is compare two values, and it is binary, much like the less than, greater than, and equal to operators. However, rather than returning a Boolean value of true or false, the spaceship operator returns -1 if the first value is less than the second, 0 if they are equal, and 1 if the first value is greater than the second. So the conditional aspect of this operator is internal, and it is equivalent to what could be written as an if, else statement. In this program, the spaceship operator is applied to three sets of values, 3 and 5, 5 and 5, and 7 and 5. These comparisons will return -1, 0, and 1, respectively. Executing the program, we can see that the three comparisons return these values exactly, -1, 0, and 1. This is just what we would expect. Again, the spaceship operator is not necessary. The same thing can be accomplished with an if, else statement. However, the spaceship operator does offer the convenience that only one comparison is needed to determine the relationship between two values.